know I don't have my website, but here you go. This is your pre-exam. The first question on the exam is an absolute value equation. Whenever you see one of these equations, the first thing you need to think is isolate. You want to isolate the absolute value brackets. So the first thing you're going to do is add 4 to both sides, which gives you 3 times the absolute value of a minus 5 is equal to 18. We are going to divide by 3. So the absolute value of a minus 5 is equal to 6. Now that you've got it to this point, you need to take it and set up 2 separate equations, one equal to positive 6, the other equal to negative 6. The only thing that changes is the sign of everything on the right-hand side. And then you solve both of these. If you add 5 to both sides, you get that a is equal to 11 here. If you add 5 to both sides here, a is equal to negative 1. Your final answer would be written. A is the set of 11 and negative 1. The second problem is a system of equations in which you are trying to identify which x and y satisfy both of these at the same time. Your goal here, it's already set up for elimination, is to get the coefficients of one of your variables to be the exact same number, but one plus, one minus. Since your y variables are already plus and minus, we can change the 3y into 6y and we will accomplish our goal. So in order to turn 3 into 6, I have to multiply by 2, which means I have to multiply everything up here by 2. This creates a new equation, which is 4x minus 6y is equal to 14. Combining the like terms of these two equations, you've got positive 3 and positive 4, which gives you positive 7x. 6 minus 6 is 0y. Here's your equal sign. And 14 and positive 42, they're both positive, is a positive 56. Solving this equation for x, we divide both sides by 7. So x was equal to 8, but you're only halfway there. You need to finish this problem off by substituting x back into one of your original problems. I'll use this one. 2 times 8, because x is 8, minus 3y is equal to 7. That's 16 minus 3y is equal to 7. Subtracting 16 from both sides, you get negative 3y is equal to negative 9. And dividing both sides by negative 3, y is equal to positive 3. You have found a point on a graph, and it needs to be labeled as an ordered pair. The answer to number 2 was 8, 3. Number 3 is another system of equations, but there are 3 equations with 3 unknowns. You want to try to identify the equation that has the simplest or the least amount of information, which would be this one. There's only one variable, and so you can solve this equation right now and find that t is equal to 4. Once you know t is equal to 4, you're done with this equation. Look for a second equation that has t and only one other letter in it, if possible. Well, that would be here. Since you know t is equal to 4, then s is equal to 2 times 4. Excuse me, s plus 2 times 4. My board is messing up on me here. Is equal to 5, which means s plus 8 is equal to 5, so s is equal to negative 3. Now that you know t and s, you can put both of those pieces of information into this equation, where 7r minus 3 times s, which is a negative 3, plus t, which is positive 4, is equal to 20. And we can find r. 7r plus 9 plus 4 equals 20. 9 plus 4 is a positive 13. Subtract 13 from both sides to get that 7r is equal to 7, and divide both sides by 7 to find that r is equal to 1. So coming back up here, because what we just found is an ordered triple, and the order that you put these in is alphabetical order, R, then S, then T. So your answer would be written 1, -3, +4. Number 4 is a radical equation. Isolate. Just like the absolute value equations, you need to isolate the radical. That means you need to get rid of this d over here. And when you do, you're going to be left with the square root of d squared minus 8 is equal to 4 minus d. Now, if the entire left-hand side is under a square root, you can simply undo that by squaring it. But what you do to one side, you must do to the other. And be careful here, because when you are squaring 4 minus d, it means you are multiplying it by itself, and this is a FOIL problem. Taking the square root of a number squared simply gets rid of the radical. You still have d squared minus 8 over here. All right, so doing FOIL, I have first times first is 16. My outer terms give me negative 4d. My inner terms give me negative 4d to add up to negative 8d. And last times last is positive d squared. If you try to bring all your d squareds over to the same side, what happens is they all go away. And so now you simply have an equation with d in it. If I subtract 16 from both sides, I have negative 8d is equal to negative 24. Divide both sides by negative 8, and d is equal to 3. Number 5, you do not need to set it equal to 0 because there's only one term with x in it. So what we're going to do is isolate x squared. We're going to start by subtracting 7 from both sides to get 9x squared is equal to negative 3. I'm going to divide both sides by 9 to get that x squared is equal to negative 3/9. Once you've divided both sides by 9, you could reduce your fraction, but remember you're going to have to take the square root of both sides, which means you're going to have to take the square root of the denominator. And it's already a perfect square, so just leave it that way. When you take the square root of both sides, you have x equals plus or minus the square root of negative 3, pull out an I because it's imaginary, over the square root of 9. And this was your answer for x. Hold on, I'm having a little trouble here. Okay. Number 6, there are two terms with x in them, so you have to